Get those last ideas in there.
Forgot my backpack.
You
forgot my backpack at home, yeah.
Okay, that's, yeah, you kind of need to go back to that. Tell us when you remember to put up your phone. Yes, you do. Alright, just so you're aware, I'm collecting so we can go over these. 3, 2, 1.
I'm not ready.
Yeah, I figured you weren't quite ready. Alright, let's go over these quickly. So open and review workspace. So the very first one, it looks like we're in pretty hefty agreement overall that this is a what type of function? Exponential. Right here, I see reasoning. I love the reasoning, but notice it says it is using a multiplicative inverse, really just multiplication, but is a linear function repeated multiplication?
No, it's repeated addition.
Okay, linear, remember, has that additive rate of change. And if you look here, right, which is not easy to see, but to go from 2/3 to 2 to 6 to 18, what's happening? We want to notice it's multiplying by 3. And remember, what operation shows repeated multiplication? Well, just which operation? An exponent, which is why we call it an exponential, right? So then here's the equations. Okay, I want to point out, I said if the function is linear exponential, write an equation. I meant for this particular function. So we need to break this down a little bit. Anyone know what's wrong with this equation?
The x ain't on the exponent.
Okay, remember if we're repeatedly multiplying by b an unknown number of times, it's raised to the x. By the way, we are going to have an understanding check involving these things tomorrow. You need to be aware of, one, how to identify each type of those functions. We should have notes on it. And then if you're going to write an equation, you got to know what the equation is, right? So, what is the general correct equation?
That one, y equals 2x.
Just in general, what's the correct equation?
Y equals a plus times bx.
That's a times bx.
Y equals a times b to the x power.
Remember, it's raised to the
Yeah,
x.
because I put it, but
Yep.
I didn't know you meant to put it for the equation.
Yeah. If the function is linear exponential, write an equation, I guess I should have said for the function. But what do we mean by a?
That's the y-intercept.
Do not forget, that's the y-intercept. So why were a handful of people saying 2? Let me change this really quickly so it might be easier to see.
That's right.
But you're not telling me why people
I'll cut the x value is 0.
I can't really see. Nope, that's not what I want. JK. We can go back. Alright. So, because why? Why is the 2 my y-intercept?
The x value is 0.
The x value is 0. Do not forget, for a y-intercept, the x value is 0. And for an x-intercept, the y value is 0. Okay? So my y value for the y-intercept is 2. And we already said that what's the pattern? Multiply by 3. Does anyone remember what the term is for that multiplicative rate of change? So remember the reciprocal is the multiplicative.
You're talking about the identity.
Listen to the question. First off, what is the reciprocal? That's called the multiplicative inverse, okay? But there was a name for that multiplicative rate of change. I like what Iona's at least doing of looking maybe at our notes from that dream job salary task where we looked at linear versus exponential. I'll give you a hint. Say it again. I was going to say, remember it's repeatedly happening, so it's constant. And what's the term for something that we multiply? It starts with an F.
No.
It starts with an F, things that we multiply, factors, right? Okay, that constant factor is 3, and because I'm repeatedly multiplying by 3, it's to the x. We need to pay attention to that. We need to know how to write that equation. If you were struggling with that, this video is going on YouTube. As a reminder, you can look at it as you study for your understanding check tomorrow. All right, the next one was this function, which the majority of us said linear. I got one exponential in there. But what was the reason? Notice I'm asking you the reason because on understanding checks, you're going to have to do what with your answers?
Justify.
Justify them. Tell me why you said what you said. So linear. What do we see going on with these numbers that makes it linear?
Addition.
Yeah,
Constant additive rate of change?
yeah,
Where do we see that idea?
Plus 4 and plus 3.
yeah.
Plus 4 on the x.
And plus 3 on the y.
So remember, can we just look at the y values?
No.
Okay, so plus 3 and plus 4. And so, yeah, that's linear because it's got that constant
Additive.
rate of change called a...
Additive. What?
What's the constant additive rate of change called? Not a factor. Remember, we multiply by factors. Say it again.
Slope.
Slope. Remember, our slope is the constant additive rate of change for a linear function. So let's look at our equations. Okay, so we got several saying y equals mx plus b. I see y equals 3x minus 6. But we do want to notice...
Why did they miss the x?
Oof, I know. Say that third one. What's the issue?
The x.
Okay, I need you to notice if there is no x, is that the equation of that line?
No.
No. Because remember, repeated addition is shown through... What operation shows repeated addition?
Multiplication.
Multiplication. Is there any multiplication if there's no x? No. What's probably the mistake we made in this equation?
They multiplying it by x.
That's okay. We need to multiply by x. Remember, multiplication is repeated addition.
But they forget the vote.
Remember slope. How do we calculate slope?
Change the y, change the x.
I got only 2 students in here. These are the only 2. Kiwan, you got a voice? Did you know that slope was rise divided by run, or change in y divided by change in x?
Yes.
Then jump in on a conversation. Say it, right? He's not the only one. I got 2 students who are saying stuff. Get involved in the conversation. He's the only one I picked on now. I'll pick on others in the future if I don't hear you talking. Come on. All right. So remember, I made this recommendation in the past. Once you realize it's linear, write that equation out to help remind you, oh, slope, change in y divided by change in x, should have been 3/4. Notice I see down here, right? Someone probably looked at just the x and then looked at the y, got 4/3. Yeah, no, we got to make sure that we keep in mind, if you write out this equation, it'll help you remember how to calculate slope. So, 3/4 times x, because we're repeatedly adding. Now I do see that plus 0 in there. What am I missing from this equation right now? The y-intercept.
Yeah.
What is... So I'm assuming someone's referring to this point, 8, 0, but is that a y-intercept?
No, that's the x-intercept.
Notice how the y value is 0?
Mm-hmm.
Yeah. 0, -6. Thank you for getting involved in that conversation, right? So plus a -6 or minus 6 is what we want to notice. Any questions?
No.
Good, we're good. Making some sense, starting to sink in a little bit. Okay. And last question was identify the type of function shown in the table. So I see 5 of us said linear, 5 of us said, 7 of us said quadratic. I'm assuming that's what those last 2 are, and 2 said exponential. Okay, so the majority of us are saying quadratic. What makes a function quadratic?
Because it increases and decreases.
Okay.
That's how I remember.
So I will point out a quadratic function does increase and decrease, but that's not what makes it quadratic, because there will be functions in the future that increase and decrease, but they're not quadratic. Come on, what makes it quadratic?
Because it got
Linear
constant
rate of
additive.
change.
Yeah.
Well, remember, constant additive makes it
No.
linear.
Yeah. The linear rate of change.
So it has a linear rate of change. Remember, to go from 4 to 1, what's it doing?
Minus.
-3, 1 to 0,
Minus 1.
Oh, minus
0 to 1,
Minus 1.
plus 1, 1 to 4. Notice, is that rate of change constant?
No.
Is it still additive?
Yeah.
Okay, to go from -3 to -1, it's plus 2. Thank you for getting involved, right? Constant.
That's what I was looking at. That's
Yeah,
what I said. constant.
but notice that's not the rate of change, right? Remember, where did I say the rate of change is?
It's in the first
In the
column.
first
It's just in
column.
that first column, right? That first set of differences. And so if this is constant additive, This is my rate of change, but what has a constant additive?
A linear function.
So, but this wouldn't be a linear function, it'd be a linear rate of change or linear additive. I don't think I added that detail in for y'all, but I do want to point out it is linear additive because we are adding, right? So, for those of y'all giving me blank stares because you were out last Friday, you might want to go watch some YouTube videos or come into tutoring this afternoon or tutoring tomorrow morning. I'm here to help you be successful, but you got to make sure you're putting in the work when you miss class. Right, Eli? Eli, where are all the resources posted if you miss class? Because I care about you. Tell me, where are they posted? Schoology, where else?
YouTube.
YouTube, thank you, alright? I put extra time in every single day to put those videos up so that you don't have to fall behind. I put those videos up so that if you are struggling, you can get the help you need, because I know some of us can't make it to tutoring at times. So, let's get started with our agenda and class today. So, quick notes about grades. Alright, I've been behind on getting those grades in. I've been getting the active collaboration scores in, but I'm just letting you know I put in the math literacy grades today. I had 9 students and the 27 of us here who never turned in math literacy. I looked at Mathia this weekend. There's a whole bunch of us who never finished Mathia or even the first set of workspaces. Guys, if you don't get those done, you're going to get penalized and it's going to hurt your grade. Plus those things online and those homework assignments are never random. They are designed to help you be successful and learn the content well. Yes, ma'am?
You want us to do all 7?
No. Remember, it was only 5 of the workspaces. Yep. So you'll see your grade in the computer, because if you just finished those 5 workspaces, you're going to have 100, right? Because you had to work through it to get there. But if you don't have a 100, or I will say I'll make a note of if you finished it late. I'll make that note in there because it's 10% off every day it's late. I might give y'all a little reprieve since I am just now getting those grades in where it's only 2 days late at this point, but starting tomorrow it's 3 days or something like that. But if it's late, right, you get a penalty, but you still got to finish it. It's going to help you grow and get better. If you only got 30% of the Mathia done, you only have a 30 on that homework assignment. We got to get our stuff done. I will say if you want to come in during your enrichment, while I have the MacBook cart here, you can come in during enrichment and you can work on Mathia during your enrichment time or something like that. Take advantage of your resources. But those grades are going to go in, so some of our grades are going to drop significantly if we haven't turned in our homework assignments. We got to get it done. Quick note about the week. Today and tomorrow we're going to be working on something online called what is it called? You don't need to go to Clever. Oh, I got you. Do that later. I need us on Desmos in a second. Quick note about the week. We're going to be working on Desmos today and tomorrow to learn about the different forms of quadratic equations, and we need to get that done by tomorrow. Wednesday I will be out because I am going to a professional development thing, but we will start an activity tomorrow that you're going to continue working on Wednesday. If you finish it Wednesday in class, you have no homework. If you don't finish it, you get homework. Yes, sir. Always looking to grow and get better. I'm developing professionally. So I'm going to, it's kind of like a class to help work on improving my ability to teach. Huh?
Are you want to be up one day?
Just one day, just Wednesday.
Oh, what you mean, when you plan to be a college, you don't be a college level teacher?
What?
You be a college teacher or professor, yeah.
No, I'm developing to become a better high school teacher. Yeah.
Ain't no difference, my bad.
Yeah. Just develop, like professional. I'm a professional teacher. Like that is my career. That's my job. I got you now. And then after that, Miss Courtney will be leading the 2 lessons on Thursday and Friday. So get excited about that. She's got some fun stuff planned and ready to go.
Yay.
Active collaboration. Yeah, thank you. I appreciate the excitement. All right.
Yay.
Jakal's just excited because I won't be teaching you, but I understand. As a quick note on active collaboration, guys. Start talking. If 1 or 2 groups are talking and talking loudly about the math, it encourages other groups to get involved. You will learn more when you talk. The person who talks the most learns the most. When someone talks to you, respond and get engaged in that conversation. Consider their thoughts and respond to help push each other to become better mathematicians, better math students, all that fun stuff. So today we're going to work on forms of quadratic equations on Desmos. Please note the objectives. There are 3 different forms of quadratic equations. One, you've got to be able to recognize each form. Because what's the first part of being a mathematician? Noticing, describe, and then generalize, right? So we need to be able to notice or recognize the forms of quadratic equations. Well, then we need to be able to identify the key features of quadratic equations revealed in each form, right? So we're going to notice again and then start to describe things. And then finally use the features of a quadratic function in any representation to write the equation. We're looking to generalize, make those equations. So we need to know those forms. Whoops, going back. First block, type in the code 20. So go to student.desmos.com. Type in that code where it says, no, oh yeah, student.desmos. You can actually just type it right
It need to
there.
be capitalized?
Say again.
It need to be capitalized?
I don't think so, but you can just do it just to be safe.
I'm confused.
What are you confused by? Student.desmos.com. Actually, sign in before, so you may have to create an account. You might need to sign in with a Google account if you have one, or you can just sign in with Desmos using your TCSS.
It's like continue
Account?
without signing in.
Say again?
It's like continue without signing in.
Correct, but here's the thing, if you continue without signing in, then it won't save your work. So you want to sign in before you log in or enter the code. Be aware if you sign in with Google, you have to use a personal Google email.
Can I get mine?
Your what?
My Google account.
I mean, you can, but I would just use your TCSS account and you just click the sign in with Desmos link. So there's a link for sign in with Desmos. Click on that and use TCSS just because you already have to know that password to log into your computer and things like that. So again, please sign in with Desmos before you enter your account, or once you just go to sign in with Desmos. Okay? And then you might have to create an account. Sorry, I should have clarified that. If you have never made a Desmos account, you may have to create an account with your Desmos login, or with your TCSS email. Let me know if you're having trouble.
Yeah.
Yes, sir. Thank you, sir. Kenny and I just gave this to you last week, right? So once you get all that logged in, go to Start Activity. I will give some more instructions in just a second. Huh? Oh, your ankle?
If we do, it's like we moving on from this stuff. So I just like learned this stuff.
No, we're not moving on. We're adding on to quadratic functions. And we're going to reflect and practice some more with this starting Wednesday. But you can do that practice when I'm not here in class. Okay? So we're doing something new while I am here to teach, and then on Wednesday when I'm not here, you're going to practice more. Okay? You have to create an account if you've never created an account. Oh, wait. TCSS is what. Oh, you went to create Google.
I actually go to bed sometimes I I'm like a grandparent.
I know.
I ain't gonna
There should be an option to create an account.
and I be hanging up.
Like a librarian.
Have you created an account yet? Maybe enter your code first and then.
I don't know what
Did you already enter the code? Okay. Oh, you created an account. Yes, ma'am.
It's kind of blurry and then it gets big. I think it's
Yeah, that's what it's looking like. You have to enter the code and then you can create your account.
But my eyes are still equal. My adapter's coming out.
So, oh yeah, you're done.
when I go home, like the license or something.
So 100% of this.
It's 22.
No, you don't need to be, no, this is 100. You're good. Probably not all.
I don't know. I don't.
Really quickly, if you're already done, please listen to this. Omar did bring up a thing. When you look at Mathia, there's a percent on when you log into Mathia to start. That is not what you have to have at 100%. You have to have 100% of the workspaces done. All right. For those of y'all who are still logging in, go ahead and continue logging in. If you are done, I do want to point out, while you work through this Desmos activity, you want to have out your textbook. You can actually tear these pages out, M1-73 to M1-75. Those are the pages you want out of the textbook. As I said, they're perforated, so you can tear them out. But this is where you're going to take notes. This is what it looks like. All right? There's a little bit more to it. But M1-73 and M1-75. There you go. Yes? You created an account there? So my guess is you didn't use your TCS as the password. You created an account in a previous math class and used a different password. You have a password that you made over the years. Huh? You have a Gmail account? Yes, Kenny. You what? You never got one? Okay, hold on 1 second, I'll get you a copy. Alright. I'm going to launch the task so that some of us can go ahead and get started, and then if you need any support, let me know and I'll bring you, say, a textbook or something like that.
Yeah.
So,
Dawson need one.
who?
Dawson.
Dawson, you ever got a textbook?
I got one, but.
Okay, you didn't bring it with you?
No.
Okay. I'll get you something in a second. That's not right.
Hey, Mr. Kenny.
Yeah.
I left mine at home too.
You left yours at home.
Yeah.
Then I'll get
I
you
got my
something.
email notifications
Please
off.
stop and listen. I will get you something so that you can work on it today. But you need to bring it with you in the future, okay?
I got you.
Alright. So, forms of quadratic equations. I will point out. Yes, ma'am. Okay. Go grab your phone and get it. So, one thing I want to point out is this. And I went into these different equations with other previous math classes. We're only looking at slope-intercept. But when you study linear functions, there are actually 3 different equations that you can use. Slope-intercept, y equals mx plus b. Point-slope form, y equals m times x minus x1 plus y1. You might have also seen this one in the past as y minus y1 equals m times x minus x1. That's another way to write that point slope. Or the standard of ax plus by equals c. You don't have to know all those from me, you just have to know slope-intercept. By bringing each of those things up, because each of those values, right, not the variables, but the a, the b, c, the x1, the y1, they are connected to key features of the graphs. And you can often find these exact values in the graphs. For example, right, 0 comma b is the y-intercept. x1 comma y1 is just any point somewhere on the line. So the parts of the equation connect to parts of the graph. So now we're going to study quadratic functions. And I'm going to go ahead and tell you what the names are. They're on your graphic organizers, right? We have the vertex form, y equals a times x minus h squared plus k. There's the standard form for quadratics, ax squared plus bx plus c. And something known as the factored form, a times x minus r1 times x minus r2. These names are designed, or they make sense if you understand what we're looking at. But what we need to do is explore what each of those numbers mean. Now, are you exploring what we mean by x? Good guess, guys. Any guesses?
Say it again.
Are we exploring what the x means in each of these equations?
Yeah.
Yes.
Yeah.
You think so?
No,
Because what do we mean by x? That's what?
I said, no, never mind.
Come on, what is x?
Slope.
X is your slope? I'd like to guess, but come on, what symbol do we use for slope?
X.
No. Say again, Anthony? M. Guys, if we didn't know that, you're good, Keelan. We got to learn from those mistakes. It's okay. We got to know that M is slope. Come on, what do we mean by x?
L.
What's
Oh,
Sorry, variable.
that's our variable. Which variable?
When does it get multiplied?
Independent?
Say it again.
Independent.
Independent variable. Remember, that's my input or independent variable. We got to know that. It's not just it's getting multiplied. It's a variable. So we're not going to change the variable. It's x. What we're going to be exploring are the values that a, the h, and k from vertex form. A, and we're actually going to skip the b and focus on c in standard form. A and R1 and R2 from the factored form. So, when you get started, you're going to look at something like this. It says adjust the value of A and observe what happens. You can't see anything because I am on the teacher view. But if you look at the student view, right, it just says adjust the value of A and observe what happens. So you're going to slide this value of A and see what you think is happening to that graph. When you move to the next slide, you're going to describe what you see. Now, I will also point out, is this vertex form? There are terms on here, right? We're going to fill out some of these terms as we get further along and as we get into different details. But some of these you already know. Like, which terms do you already know on here?
Everything except for concave.
Everything except for concavity, right? We should know vertex and y-intercept and axis of symmetry and x-intercept.
Yeah.
The only thing we haven't talked about is concavity, which actually I meant to mention that before. Thought I did.
The state of quality of being concave, what does that even mean?
I don't know what you just said.
I said, the state of quality of being concave, what does that even mean?
So I want to point out, you see how this is kind of going up with that curve?
Yeah.
So we call that concave up. When it's going down like this, it's called concave down. That's the language that we use for it. A way that one of my high school math teachers helped me remember it is it's concave up like a cup. Right? You could pour water into this thing and it would hold a liquid, right? Concave up like a cup. Whereas concave down like a, oh yeah, it's exactly what it is, right? Concave down like a frown. Looks like someone frowning. Huh?
Or upside down cup ain't gonna hold no liquid.
Correct, yeah. It's just the frowning, rhymes.
Kill the whole.
Alright, so, no. Alright, so, within your small group, start exploring. Pay attention to the directions, right? The very first thing is looking at A in vertex form. What is it doing to the graph? And then we're going to look at different values. But once you finish one, move on to the next. Now, before you move on to the next, what should you do within your small group?
Talk.
Talk with each other, right? We should have a consensus within the small group about what those different values are doing. Make sense?
Yep.
We good?
Yep.
All right? So, Ishmael, when Destiny talks to you and says, hey, Ishmael, this is what I think that A value is doing, what are you going to say? You don't know yet, but
I'll say something back.
you'll say something back like, oh, that might make sense. Or, hey, I was seeing it this way. What do you think about those ideas, right? Bouncing ideas off each other to grow and learn. Any questions?
No.
Let's get to work.
I have to.
All right, Dawson, you need a copy of